Today we are continuing our study of Chapter 13 with Lesson 2, which I have split into two parts. So today we will be doing Lesson 13A, What is Heat? So we have two objectives today. You should be able to define heat as thermal energy transferred between objects at different temperatures and compare conduction, convection, and radiation. You have a brain pop that you need to go back and watch and also complete the quiz. So heat is the energy transferred between objects that are at different temperatures. So when two objects at different temperatures come into contact, energy is always transferred from the object that has the higher temperature to the object that has the lower temperature. So it always goes from hot to cold, hot to cold. So if you've listened to that song, which I encourage you to do so because it will get stuck in your head and you will know this, temperature changes occur because energy is transferred from an object that has a higher temperature to one that has a lower temperature. Here is another Eureka video that you will come back and view. So we know that heat is transferred in the form of thermal energy. We've been saying all along that you can swap those terms out. Thermal energy is heat, heat is thermal energy. We know that thermal energy is the total kinetic energy of the particles that make up a substance. Remember, kinetic energy is energy of motion. So thermal energy depends partly on temperature and partly on how much of the substance there is. You're going to come back and watch this short Bill Nye video clip, which will explain, if you'll remember back, the ice sculpture, the swan. Comparatively speaking, there's more of it, so there's more heat energy there. So thermal equilibrium is the point at which two objects that are touching reach the same temperature. So they are equal in temperature. Thermal equilibrium. There's no net change in the thermal energy of either one occurring at that point in time. They are both the same. So here's an example, real-world example, of the transfer of thermal energy. We have an ice chest or cooler with a drink in it. And you can see the motion of the molecules that we've been talking about. So energy is transferred from the particles in the juice, because they're warmer, to the particles in the bottle. These particles transfer energy to the particles in the ice water, which causes the ice to melt. It always goes from hot to cold. Thermal energy continues to be transferred to the water even after all the ice has melted. And then eventually the juice, the bottle, and the water all have the same temperature. So they have reached thermal equilibrium. The juice in the bottle have become colder and the water has become warmer. Hot to cold. So let's deal with conduction, convection, and radiation for just a second. Conduction. If you put your hands together, they're touching. So to have conduction, there must be direct contact. Direct contact. So the transfer of thermal energy from one substance to another through direct contact is called conduction. When such substances touch, their particles collide with each other. And when the particles collide, the particles with the higher kinetic energy transfer their energy to those with lower kinetic energy. And just like with the ice, this transfer of energy happens until all the particles have the same average kinetic energy. Think back to the last chapter. The law of conservation of energy states, energy cannot be created or destroyed. It simply changes forms. Here's another Eureka video that you're going to come back and watch. So conduction, they have to be touching. Convection is due to movement. So you think of the rise and fall of something. Think about the water cycle, the rise and fall. So transfer of thermal energy by the movement of a liquid or a gas is called convection. So we know that as water heats up, it becomes less dense due to those molecules being separated out. Don't touch me, don't touch me, don't touch me. The warmer water rises through the cooler water above it. So you've got a pot on the stove and you're boiling the water. At the surface, the warm water cools, becomes more dense. The molecules become tighter together. The cooler water then sinks to the bottom, and the cycle simply repeats itself over and over and over and over and over. So conduction, transfer of thermal energy through direct touch, direct contact. Convection, transfer of thermal energy by the movement of a liquid or a gas. Come back and watch this video. It will show you what we just talked about. And our last transfer of energy we're going to discuss today is radiation. So this is the transfer of energy by electromagnetic waves. We call them EM waves. All objects radiate these electromagnetic waves. But unlike conduction, direct contact, and convection, up and down, radiation can involve either a transfer of energy between particles of matter or an energy transfer simply across an empty space. Think about how we get warmth from the sun here on Earth. It radiates to us. So that transfer of thermal energy from the sun to the earth is through radiation. All right, this is the end of lesson 13.2a. When you come back and watch this, you're going to watch the video on the next slide, which is another Eureka video, and that will conclude your study today of lesson 13.2a. We will pick back up with this lesson in the second half with lesson 13.2b.